So I guess I do start. Okay, welcome. Thanks for coming. I want to talk about today why or at least I think your business is more complex than, for example, Netflix. I skipped it from the title actually because I'm still a bit afraid that they sue me for that sooner or later. So I'm trying to skip that from wherever possible. I recently learned last year, actually, you might have heard that sooner than me, but I learned last year about that great acronym, which is called FAMGA. Not sure if you know that. So that's actually the big internet companies like Apple. It's still the G is still for Google, not Alphabet, how it's named nowadays. But there's a great discussion. If you have some time, you can Google it. There's a great discussion. What could the acronym be if they now name it Alphabet? But they don't come up with a solution, so it's still called FAMGA. So there you see that's quite a huge companies with a huge market capitalization, a lot of money involved. But for example, Netflix is not on that, which is great because there's another acronym, which is FANG, and that's, I think, even the older one, which is about Facebook, Amazon, Netflix, and Google. And I think that's the more, from a technology perspective, maybe even the more interesting one. And I picked Netflix as an example. And if you Google Netflix, the great thing about, for example, Netflix is they're pretty transparent for the technology they use. So you can find a lot of things online for their stack, for their technologies, and so on. They're, on the other hand, also great in reinventing a lot of things, but that's another thing. And that's just one slide I picked. You can find other ones as well, but there are a lot of things are all the same normally. So they're using a lot of like non-SQL stuff like Cassandra or S3. They're using a lot of microservices. That's what we want to focus on today. They're using, for example, the Elastic Stack and so on and so on. They're using Kafka. There was a talk about Kafka today already, and a couple of other things. That might differ a bit from what you find when you search Netflix, but you find more or less this kind of stack. And what you don't have on that stack, and what I want to emphasize on today, is orchestration. There's no orchestration at all on the whole slide. If I say orchestration, I mean something like I have to do some things in order to achieve some goal. So for example, I will later on come to the example of a simple order application. And there, if you want to order something, you have to do a couple of things, like I order it, I pay it, the goods are packed in a parcel, they're shipped to me. So there are a couple of steps involved in order to get that going. And if you look at the business model from Netflix, that's quite an easy business process they have, actually. So the main business process is like you click on I start. There's even not any other alternative to get going. So that's the site when you come there. There's not a lot of information, not a lot of options. You can create the abo, and as soon as you started the abo, you might have to pay later on, and you can start watching. So that's quite an easy business process, how to register for Netflix. If you're looking at most of the companies I know, it's much more complicated. I mean, if you do mail order, it means like you really have to pack goods. If you look at, for example, Zalando is one of our customers, they even have like different stocks. So they have to check where the trousers and the shoes might be in different stocks, but I want to ship one parcel to the customer, but that has to be there tomorrow or something like that. A much more complex business process. If you want to do an insurance, nowadays you have to do a lot of things. If you want to open a bank account, if you want to do whatever it is. So most of the business processes out there are much more complex than what Netflix is doing, even if they scale out much more. And the fun part is, I wanted to use that as a motivation to overcome that. What I very often hear is that, yeah, we do microservices. We learned that from Netflix, and Netflix doesn't do orchestration, so orchestration is somehow evil, which is not even true. And soon after I handed in that talk, Netflix came up with an orchestrator. So somehow they also saw that missing link in a microservice architecture about orchestrating things. And that's what I want to talk about today. But I want to do some groundwork before we come back. I make that actually very fast, but I try to tackle the most important things. So one key change I see nowadays, and I think that's an important thing to get started with, is that the world is getting much more complex. The example I like most is the one on the left. Like, we currently have a customer in logistics. So what they did in the past, and they still do till now, is they built a warehouse software. So that means they have one warehouse, there's one warehouse system, software. That software is 3-tiered, so it's database, application layer, front end, like you did it for like 20 years. But now they start to have very different requirements. They start to have something like, oh, we have a stock on the road, we have distributed stocks, much smaller stocks. We want to do same-day delivery in the big cities, and these kind of requirements you have. So it's no longer a stock warehouse system, but it's kind of a platform, because you have to connect all these all these small little stocks in order to talk to each other. And that means the overall system gets really complex, much more complex than what we did in the past. And you can see that for a lot of domains. I don't want to go through all the examples. You might even have much better ones than I have. But what you see is that really the complexity grows very much. And that's also, from my perspective, why all these paradigms, which are, some of them are around for a longer time, but now really come back and start to be applied in real life. So the ones I want to talk about today is microservices in a bit. I want to do that event-driven. So event-driven architecture is kind of an old term, but it seems to start being applied nowadays, very often in combination with microservices. And also that Eric Evans' book is quite famous nowadays, but domain-driven design. If you look at the Java community, mostly because microservices are picking up a couple of the ideas, but there's even more in it. And that's what I want to go over today a bit. If I start with microservice, I don't want to do all the microservice definition, all the microservice rules. But for me, the important things are you break like these warehouse stock software, which is kind of a big monolith, into separate services. The services are kind of independent. So they should really be independent. So you can change them without having to change anything else. You can deploy them without having to deploy anything else. That might be by your own team. So the team is responsible for exactly one microservices, normally full stack. So they also are responsible, for example, choosing the persistence technology, the database. So I don't have like any central database. I don't have a central database team. And if you do it like, yeah, I see that from time to time, not too often, but you might even operate them. Or at least the DevOps guys are close to your team or within your team. So you're also responsible for running that on a live system. So that's, in a nutshell, what I see in microservices. And if we look on how they communicate, and I come back to why this is important in a minute, we could imagine it like event-driven. That's what I said. I see a big trend towards event-driven. And then you could imagine it like, okay, I have like 3 microservices, for example, and they have an event bus, or you can call it message bus. For me at the moment, that's more or less the same. So I have kind of a bus, which is a central infrastructure. That's true, but that's kind of the accepted thing. So you have to have something central. I mean, the same thing like the network is there, or I use TCP/IP, or a couple of central things are accepted, and the bus is typically accepted. And then I publish events on the bus. That's what also event-driven is about, which if you look at domain-driven design, there are a couple of things how to do these events. But the basic idea is that, for example, microservice A did something, he pushes an event on the bus, which doesn't have a recipient. That's one important thing. So he doesn't know he sends an event to C. He doesn't care. He just publish the event, and it might have some payload. Yeah, that's the basic idea. So the idea is decouple them. So temporal, so that's kind of a message or event bus, so it has some kind of storage. If C is not available, the message gets delivered later, but also structural, because I don't have to know about C or A from the other microservice. That's now typically the moment where a lot of people ask, isn't that like SOA? Isn't that over? Is that kind of the old idea of having these ESB and having the services and connect them? And one of the important differences is that you might recognize the guy with the hat. That's Martin Fowler. And he said something very famous. I heard that already today 2 times. Smart endpoints and dumb pipes. So that's kind of the counter architecture we do now. With the ESB, we had like a smart pipe. So I pushed some message there, and the pipe, the ESB, had some logic and knew where to route that message. And this normally meant, and this is why it didn't work, that when you change something, you normally had to deploy, like redeploy service A and maybe some configuration in the ESB at the same time, because otherwise it doesn't fit. And that's why it didn't work out. But what's done now is that you use it like a dump pipe, really dump pipe. So I just put a message there, and it's like a topic, so anybody can subscribe, but I don't care. There's no logic involved in there. And then I have smart endpoints, which are listening there and deciding which messages they want to take or which events they are interested in. So that's the groundwork. The why you might want to do that is that you now have independent teams caring about the microservices. You might want to change them independently, and you can also bring them down independently, for example, if you want to migrate or upgrade something. Okay, so far that shouldn't be that new, I guess. Let's see. So that's great. Let's make an example. I already said that. I want to use a simple order application. So yeah, you can, I think everybody knows that. So you want to have something, you order it, you pay, and that is something my little daughter, she's almost 3, always says, and now Manu brings it, because Manu is our DHL deliver girl, how you say that? And she thinks, I think the whole world is brought by Manu, but normally it works like that. I place the order, I pay, and then she brings it. And if you implement that with microservices, could be that you shape the microservices like that, if you know a bit of domain-driven design or bounded context or aggregates or whatever concept you want to put behind there. It could a bit be like that. You have a payment service because you have to handle payment. It could be an inventory service because you have to care about your stock. It could be a shipping service because you have to get the parcel on the way. Right? Could be sufficient so far. Looks promising for that domain. Now let's have a look at the typical event flow. So when you do that event-driven, it means you might start with press of a button. That means an order is placed. Then that means the payment, okay, knows, oh, there was an order placed, I have to do the payment, and whenever the payment is done, there might be an event payment received. Then the inventory sees, oh, the payment is there, I can now commission all the goods, and whenever I'm done, when the goods are there, ready to get packed, the goods are picked. And then the shipping component knows, oh, the goods are there, I have to organize the shipping, and the label, and whatever, and whenever that's done, the goods are shipped. So far, it's so understandable, I hope. So that's kind of an easy thing. If you look at the implementation of it, it's also quite easy. So you might have that event bus. So what you see is a couple of things here. So the payment does never talk to the inventory directly. So that's one of the important things here. So every communication goes over the bus. So far, so good. So that's kind of a decoupling here. If you look at the payment service, there's one interesting detail or interesting problem you might get now is the payment service has to know the order placed event in order to do so. If you have like these event-driven microservice architecture, it means there's the bus, and the payment service listens to the bus and says, oh, there's an order created event, I have to do payment. That's the, I would say, naive or purely event-driven approach. And that could get really problematic if you have that payment service maybe being responsible for different payments. So that's one of the problems. It has a couple of other problems. I come back to that later. So that means whenever you have a new client, a new consumer for your service, you have to adjust the payment service in order to subscribe to the right event. That's kind of a not so good idea. And that's, by the way, again, the guy with the hat, so Martin Fowler, also, that was kind of cool. He just published an article last month, or it was January, already March, so months before, with not giving a lot of details. So it was kind of a short article where he just said, oh, he recognized something without going into the details. But he also said, oh, it can become problematic if there's a logical flow that runs over various event notifications. The danger is that you very easy make nicely decoupled systems with event notification without realizing that you're losing sight of a large-scale flow. There were a couple of other things in that short article as well. So there seems to be kind of a smell. What could solve that is we named that event command transformation currently. So an event, that's a clear thing. An event is something that has happened in the past. It's just like a notification. Somebody might act on that or might not. It's just I'm telling, hey, the order was placed to whoever it concerns. There's a second concept. You can also put that in a message, which is a command. A command is something where I say something has to happen. It has normally kind of a clear recipient, and it's not like a choice. If I say, for example, do payment, that's a command. Somebody has to do the payment. It's not like, might be somebody interested in that. No, there's one recipient who has to do it. And the idea is that in order to get that right in these event-driven microservice architectures, to do a transformation in between. So you have to have some component which translates basically the order placed event into the do payment command. So that allows that the payment service doesn't have to know about the order placed event anymore. That's the whole idea. What would fit most logically in here is, I would call it an order service. I mean, it fits in the domain. You have some kind of order. You might even have like an order entity where you store a couple of things. So that fits pretty nicely. So I would add that actually to my microservice landscape. If you look at that event command transformation in detail, so we have a couple of them actually. So from order placed to do payment, that's one of the transformations. Once the payment is received, we don't want to listen the inventory to that, but also translate that. Oh, the payment is received, so we want to pick goods. If the goods are picked, we want to translate that into, oh, no, ship goods, please. And if the goods are shipped, we might translate that into a new event like, oh, the order is finished now. So these transformations are happening all over the place, basically. When I discussed that slide the last time, actually what happened is, it looks again like the Zoosaurus or the ESP. You have that big thing in the middle here, so that's kind of ugly, isn't it? And I would say no, definitely not. So it's completely different things. So that order service is also like a microservice. So we don't put that logic, like that transformation logic, in the ESB or something like that. It's an own microservice. It consumes services and it publishes new services. So that's the idea, what it does. Now we can come back to orchestration. So that was kind of a groundwork. If we look at the overall order process, what it has to do is a couple of things. Like, for example, in that order, we come back to the order later on. Do payment, pick goods, ship goods. Sounds kind of makes sense. Everything is only that command event transformation. So I send out the command, I wait for the I have done it event and do the next thing. So you need to implement that. I think there's no real way around that. If you look at it, how you can do it, it's the same thing. You have the event bus in the middle. So the big difference is now they are still not talking to each other, but whenever you see that line to the service, it's never something from another domain. So here we don't have like payment received. We only have the commands pick goods and goods picked. So that's kind of a clean way to talk to the service. So that's kind of cool again. So we definitely already improved our microservice architecture. There's the next problem we might get. So the payment service might be slow. It depends. I mean, nowadays we're used to PayPal, which is kind of fast, but it might involve some credit card handling, and then whatever, the credit card fails, and you might want to be nice to your customer and inform him and say, hey, your credit card failed. You have like, whatever, 2 days to update it, and then we can still do the order. If you're too late, we cancel it, but we give you some time to do that. Or the goods picking might involve somebody really walking through the warehouse. That takes time. So it's kind of a slow thing, and that means these kinds of these services, I call them long running. So that takes some time. Long running means could be a couple of seconds, could be a couple of days, could be a couple of weeks. So that actually doesn't matter too much. The thing is, it also makes the order service long running, and it makes you to handle state. So as soon as you have something long running, you have to think about state handling, because that means you have to handle situations like what I said. You can update the credit card, but you have 2 days. What happens after the 2 days? You have to monitor these 2 days. You might have to answer questions like, where is the order? Oh, I wait for the shipping. The shipping is slow. The shipping hasn't responded. So you have to handle that state somehow. And that's actually where I come in. That's why I find that topic so interesting. I haven't said who I am, so I quickly do that. So my name is Bernd Rücker. I'm one of the founders of Camunda. I'm basically all my life worked in workflow. So I have kind of a background with state machines. So that's, well, for me, that is a completely logical thing. Yeah, to do actually, and to use something like, for example, we see that in a minute, BPMN. Does anybody in the room know BPMN? Almost none. Does anybody have a prior experience with any workflow engine, orchestration engine, BPM engine? A couple of, okay. So that's my world actually for the last 10 years, but also this world is changing from that, what I said earlier, from the 3-tiered architecture or ESB and BPM, SOA things, to the new microservice world. And I recently blogged about what I named the 7 sins of workflow. If you're interested in all the sins, you can go on my blog. We only have time for 3 sins, so I give you 3 sins. And the first sin is, as soon as you have that state handling, as soon as you have that order, that orchestration thing, you will have to handle a couple of requirements. And it doesn't make much sense to do that without any help of an engine, because what always happens, so at least when I saw it, and I see that like twice a month, I would say, what always happens if you're doing no engine, you store the state somewhere like in a database table. You said, okay, the order is created, and then you have like a Boolean flag, the order is paid, and you have like an enum, is it shipped or not? So you start adding this kind of state to your entity, and normally it ends up that you start building your own engine because you have some more requirements about the timeout handling. Then the business might approach you and said, I want to be more flexible on that. So it normally ends up there, which means just a couple of work to also have an engine, which is normally not that good as what you can get on the market, even open source. So it's not a good idea to do from my perspective, but I'm kind of biased there maybe. And the other thing, and that's I think why a lot of people would never think of using such an engine for this use case, is that most of the BPM, so there it's often called BPM instead of workflow, vendors out there ship something I call a zero code suite. So that's the idea of the business, whoever that is, can implement a process without involving IT at all. So a business guy can draw this stuff, click on a magic button, somehow wire the services, and then it deploys and it all works. That was sold, I think, for 10 years. It was sold very successfully, but it was never implemented very successfully. Normally ended up with that tool being passed over to the IT, and the IT somehow hates it because they have to enter some kind of weird proprietary code in some small like text boxes or whatever. So it's kind of not working. And there's something in the middle as well, and I want to come back to that in a minute. So what I would, for the moment, imagine is that for that state handling, for that event command transformation, in that use case, I want to use an engine, because that gives me the state, it gives me some kind of visibility of the process, might be BPMN, we see that in a minute, and normally you get some tooling, so you get something on top, which is kind of cool to have. If we look at that example, this is BPMN. For everybody who doesn't know BPMN, that's the BPMN process. It's an ISO standard, so that's why it's interesting. It's basically used worldwide by most of the engines and vendors. It's normally taught in university and so on and so on. So that's kind of cool to use. So that's a start event, it's called. So something is started whenever an order is placed, for example. Then I do exactly what I had on the whiteboard. I do the payment, I pick the goods, I ship the goods, and then I might issue an event like order completed. So I can model that in BPMN very easily. I did something to, in the background, which is, if you have a good engine, which is possible to hide something behind the box, in my case, I have hidden that whenever I say do payment here, it basically means in the background what we had with the event command transformation. I send a command, and afterwards I wait for the acknowledgement event. Because only if I get that, the service was successfully done, right? So that's kind of hidden behind all the boxes. So far, understandable, I hope. The cool thing, and we see that in a minute in the demo, you can directly execute these kind of models. So they are in the background, it's an XML file, you can give it to the engine, and you can directly execute that. You could also do that for payment. The example I tried to explain earlier is exactly that. And that's, I think it already helps to have the picture to explain it to you. So I say, whenever I get that command, I build a credit card that might be like doesn't have to be an event. It might be like a SOAP service or a REST service to swipe or whatever it is. So I just build it. If that works out, fine. If not, if there's an error, I might go another route and sending something to the customer. However I do that, it's not set here. That might be like another microservice who is responsible to talk to the customer in whatever form. And then I wait for new credit card information. And if I don't get them in time, I basically cancel. So that's kind of the idea here. Doesn't have to be the best process for that, but it can be modeled in BPMN. And one core idea now, and I think that's a very different thing to what workflow did in the past. One core idea is that if you have these microservices, you can use like an engine and BPMN within one microservice, if you like. We said earlier, every microservice, every team has kind of technology of choice. So they might use such a thing or not. It's their decision and it should be left to the team. That's a cool thing. But if they have these state handling problems, they should not follow that 7 sins and they should maybe leverage such an engine. But all of them have their own engine. They have their own process. So what you don't have to do, and what was actually very often done in the past, as soon as you set BPMN or process modeling or workflow, it was kind of a reflex to model the what's often called the end-to-end process. So like from the beginning, something like, okay, whenever there's an order placed, we build a credit card. So we don't just say payment service. We say do the billing. We do that on our own. If there's a problem, we handle that. The same for picking. If there's a problem, we might do reorder and whatever. So we basically have all in one process. And that's kind of a big, so that refers to the 7 sins. That's what I call the BPM monolith. That might be a good idea if you have somebody in the company who feels responsible for the whole thing and wants to do that. But if you take microservice seriously, on the level of the order, you shouldn't care about these details. It's not your business. Your business is that you do the payment before you ship the goods, which doesn't have to be that way. I have changed scenarios later where we could say something like, oh, we want to do payment first only for not VIP customers. Otherwise, they get an invoice or something like that. That's the ownership of the order service. So I can decide that within that order service. And how the payment is done in detail is part of the payment service. That this is also BPMN is kind of a coincidence. I don't have to know that on the upper level. So that's the idea here. And this was kind of a big, let's say, fight over the last years because I'm coming from that BPM workflow community where I have to confess I'm also somehow automatically drove towards that thing. And if you're kind of a microservice minded, you're going that way, but somehow then your mind says I cannot use BPMN in there, because then I end up with that. And that was kind of the fight we had for the last years, basically. It took me a while to figure out what the core problem is. I hope we keep the projector. And then were these blog posts, for example. I had quite a longer discussion with that guy, which is kind of not true. So I'm not sure if there's anybody not able to read German. It's kind of, whoever does microservice correctly doesn't need a workflow engine and BPMN. And I think that's due to that misconception. And I think that's a different thing. So what you need in order to make it happen is something like an engine which you can really embed within the microservice when you need it. If you don't need it, you don't do it. If you need it, it must be very lightweight. So I have in the demo in a minute, I have a Spring Boot environment. So I don't want to have everything in that Spring Boot environment. Don't want to have anything else. Don't want to have a central server. Don't want to have a complex thing to start up. So it should be easy to use. It should be embeddable. It has also to have a fitting license model. That's what I learned over the last year, that most of the proprietary vendors still base, for example, license fees on CPU. That doesn't make sense for this kind of environment, because then you might end up with one big iron machine running all the microservices in some kind of distributed virtual machines. And then you might even have to license that engine for every service for all the cores. That's kind of a nightmare. It's just not able to pay that. So it's not only a technical challenge, it's also kind of a license model challenge, which is kind of easier to solve in the open source world. But you have to take care of that. But it's possible. I think that's the important thing. So you can do that today. So it's not a showstopper. And I actually wanted to dive in a live demo to give you a better impression, because I normally don't like talks without live demos. So I wanted to do that as well. What I have here, what I show you in a minute, is this. I basically have the services I mentioned earlier. All of them for me are separate. I use Maven and Java here, so separate Maven projects. It's even not sure what I have in the frame there. So there's a starter class which has all the microservice as a dependency and can start all of them in one VM, because then you can by one command run the whole thing, which I even don't do in the demo. So in the demo, I started all of them separately in a separate JVM. I used Spring Boot whenever I required REST API. So for example, you will see my nice little shop in a minute. So that's a great piece of software, and it uses REST in the background just in order to place more order. I have kind of a monitoring application. So that's kind of a, if you want, so CQRS approach in place. So I basically read all the events on the event bus and can display them in some kind of monitor, because otherwise it gets a bit boring, because all the other services are not really visual at the moment. I use Kafka as a transport here. In the implementation I have in the demo, it's on GitHub, so you can also play around with that yourself. You could also use RabbitMQ. So I have the implementation on Kafka or RabbitMQ. It actually doesn't matter. I need some kind of bus there. Which one does actually don't care. And then I embedded, that's a Camunda logo, so that's a Camunda open source engine. Camunda, the company I co-founded, so kind of a coincidence I used that there. So I embedded that within the service. It's you can see that I have not even used Spring Boot. I could have, but I made it even easier. So it's just a public static void main, and that starts up an engine within that Java process. And what I use is so this process engine needs a relational database, can be an H2, so I start up the H2 myself. So depending on which one is first, they start the H2 internally, and then the other one connects to it. Maybe not what you want to do in production. You might want to use different databases for the services. But there's one nice little thing I could do, especially for the demo. As soon as I have that running, I can also point the web tooling we have to the same database in order to basically inspect what's going on there. Okay, so that's kind of the architecture I have for the demo. The services don't do a lot of useful things, actually. The most useful thing they can do is a delay, so we can see the events flowing better, which I might not even use in the demo now. So let's quickly have a look at that. So we might start with the shop. The shop is great. Oh, you might not see that. Here's the shop. That's it. I was kind of motivated by Amazon Dash. So you could imagine that's kind of a dash button, for example. I was too lazy to implement something because it doesn't matter. What it does, and that I can briefly show you, and that's a very easy thing, is whenever you hit that button, you get to that REST controller, kind of a Spring boot thing. It calls that place order method. Are you able to read it up there as well? Yeah. Okay, great. It actually hard codes the whole order, which is, I think, the idea of a dash button. So it's hard coded in the dash button. So that's a great piece of software. And then it publishes, and I use these event producers and consumers. It's our own hard coded class, so it's pretty easy. All over the place, and I publish an event ordered, an order placed event. Sorry, and that's kind of I just build a JSON structure. Same thing for the architecture. It doesn't matter how I do that. The idea is I publish just a bit of JSON. We can see that in a minute. Basically on the transport, and then you can see that's so it's not meant to be used in production. It was meant to be easily showable for demos. Okay, so you can see that I just use a channel in order to send it, and that channel could be now either hang on a second. Yeah, I abstracted that. So it could be either at the moment Kafka or Rabbit. So it's, you see, it's like, I mean, if I remove all the classes, it could be like 10 lines of code sending something in Kafka. So that's what it does. And then the next thing that happens, if you remember the order placed means I now have to do the event command transformation in the order service. So I go to the order service, different project. In the order service, and that's now maybe an interesting thing, I implemented different ways of doing that state handling in the event command transformation. Because I said earlier with the 7 sins, don't do that state handling yourself, which I truly believe in. So don't do it yourself. But I implemented it in order basically to show the consequences as well. So if you're interested, you can also look in that one. So that basically just have the handle event method. What I do is basically at the moment I use one Kafka topic. So all the microservices get all the events, which is fine for me here. I mean, performance is not much of an issue with that one dash button where I click once every 2 hours. And where I was going to, I forgot, whatever. So yeah, and then I get that event and I basically check if I'm interested. So if that is an event, not a command, and it's called order placed, I'm interested, so I handle it. And then I do a lot of state handling here manually. What I said earlier, like a Boolean and the enum and so on. I guess you might have seen something like this yourself as well. I see it all the time. What is more interesting to look at, I made the same thing using BPMN now, the Camunda engine. And that one, it basically, what I said earlier, it starts up the engine. So that's not a very complex thing, actually. It's like, okay, I do some tricks with the H2, what I said earlier, but that's the most important thing. So I have like a process engine configuration. I configure how much history I want to have. That's the same database magic we want to skip for the moment. And then I say, give me an engine. That's it. And then I do something like same thing. Go up. I handle the event. If it's an order placed event, what do? I basically parse my JSON in order to get a proper object. I still persist that. So I want to still have that somehow, yeah, my order entity. That makes sense. I'm actually a bit afraid that the font is too small. Isn't that the case? Because normally I'm having a much bigger font, but I think in the train I was a bit, no, not tasks. It was always on the very end, no longer. Ah, there it is, sorry. So I'm a bit afraid you cannot read that great code. So I persist the order, and then what I do, I start a new process instance, and that kicks off that BPMN process I had on the slide earlier. So I made it a bit more complex at the moment because I do the payment and I also reserve goods in parallel. We didn't have that earlier. That's a decision I made. Could be also like a business requirement. Hey, if you want to, if the payment takes longer, we want to reserve the goods for the guy. Business decision for the order. And whenever I get some other event, I'm try to correlate that. So there's an own correlation method here. So let me show you one thing first. So as soon as that service goes in the do payment service task, I attach the Java class. That's what we can do in the Camunda engine. So that might be different if you're using a different engine. And that's a very easy one. Again, it gets a producer and it publishes the command do payment. Same thing as earlier, very easy thing. I just create a JSON, which I sent over the wire. And what I do as well is I add what we call a message subscription. So I say, okay, now I wait for a message, which is called payment received. And this message subscription really ends up in the engine. And then I can say later on, whenever I get an event, that thing here, I correlate that message. I don't want to go into the details of the code. You see I think the overall complexity. It's not that complicated. And then the process moves on. If that one arrives, it also moves on. It goes to the pick goods and so on and so on. Okay? So that was almost it. I have a second nice little piece of software because if I now hit that button, actually nothing happens really. A couple of log statements and would be kind of boring. So what I did as well, I implemented that monitor. It just connects to a WebSocket. The WebSocket connects to Kafka and gets all the events on the wire. So it can display it here. So as soon as I'm connected, it's more fun to click that button. So let's do it. So what I just did, I entered an order. I create, and that's kind of a design decision. You don't have to do it, but it's normally a good idea to do. I created a transaction ID, which I try to give to every microservice in order to later on combine all the logging I have. And then you see, okay, that started with the order placed event. It then created a command, reserve goods, and a command do payment. I got back the goods reserved. I always say from which component. And then I do the pick goods. That's a nice little thing. Now you see the order is not completely correct. That's kind of it was too fast. So ordering might, especially on the WebSocket, might not be correct. But you see that somehow I got to the order completed state. So that kind of works. And what you can also do now, as we have that engine in place, we could also leverage the tooling, what I said earlier, and look into that orchestration I just did. So I could look in, for example, the payment. So I can see, okay, there were 4 payments done in today. So I did that now. I did one before the talk because I was afraid it was broken, and I did one in the train. So you can see all of them are, for example, went great because there's nothing implemented which raises any error. So I think I get a 100% rate. That's also great. And I could also look, for example, at the order, and I could also look at my specific order I just had. And then I can even see all the audit data, like at which time I passed that, or what were the variables I entered, and so on, so on, so on. So yeah, basically that's it. So if anybody's more interested in the details, let me know. We can also go through that later on. I just wanted to give you an impression of that, how that works in real life. If you want to check it out, it's on, no, screenshots, you saw that. I have the link later on the slides. It's on GitHub. You can just fork it or download it and run it. It should be very easy for you to run. You just need Maven and Java, and that's it. Yeah, so it could give an impression of how that really works in reality. Just to wrap it up, a couple of things which are interesting to look at. So far I talked about asynchronous events. You might still have that situation that you have synchronous REST calls. We heard that already today. I think I heard it 3 times that it's kind of evil, but you see it out there all the time. It doesn't change a lot, actually. As soon as you have synchronous REST calls, it's even more pressing to have something handling state, because you have to handle the situations where the REST recipient is not available, most often yourself, because then you have to have this retries and these kind of things. So it doesn't change that game a lot. What you can have a look at, and that's actually a very interesting exercise, is change scenarios, because we talked about earlier that we do all that microservice thing in order to do changes easier, right? And whenever we have a new business requirement, like we want to reserve goods, okay, you already saw that on the slide, so it's kind of an easy thing, but that could be a change, we do. And as soon as we get that requirement, what is the goal? The goal is to involve as less teams as possible to implement it. Then we are good. If I only need one team to implement that, that's great. If I have to have 3 microservices changing something, then I have to coordinate them. That's bad. Okay, pretty easy story. So you saw that thing I did in BPMN. So I had just that thing in parallel. I changed that only in the order service. That's kind of great. If you think back with that event-only approach we had earlier, without that event command transformation, you would have to change more components. I mean, as soon as you have that requirement, you would need to say, okay, the inventory service has to listen to order created, because it should reserve goods immediately after the order is created. And the payment service now has to listen to other events, whatever. We don't go in all the details, right? We run a bit out of time, but I think you get the idea. You can make much more examples. I will put the slides online today whenever the Wi-Fi start to work here, so might be in the very evening. Then you can also go through them. But you could have something like the VIP customers can pay later. In the current approach, it's very easy to add that in the order service, because you could have something like this process. And it's ownership of that service. So the order should be responsible. The guy responsible for the order microservices, order microservice should do that. And he should decide what to do. And he could decide, okay, I skip the payment for some reasons, and then I do it later. Perfectly fine. If you don't do that, if you don't have that order component doing this, then you would really have, you really have a problem, because then, for example, the inventory, I go back a slide, and you even see that the picture is helping, right? So the inventory here, no, the payment, I messed it up. But you get the idea. So inventory service has to listen either to order created, that's this thing, if it's a VIP customer, or to payment received if it's not a VIP customer. So the inventory service now has to know about a VIP customer. He doesn't care. He shouldn't care. So you get a lot of problems if you do things. There are even more things you can do with BPMN, and I skipped that for a moment. I also skipped that for a moment, just to get on track. So as a summary, as a takeaway, so I would say a microservice and event-driven go great together. I come back to that in a minute on the next slide. If you do that, you might need that event command transformation. That's a very good idea to do. And I think you have to do it actually to get a good architecture. And if that translation is stateful, which is not always the case, but as soon as you have long running, it's stateful, then you might use an appropriate engine. I think that's a very good idea. And if you take the right engine, you have a lot of lightweight engines out there, not a lot of, but you have them. And they really help within these architectures. They're not these BPM monolith anymore, which cannot handle that. So you might ask the question, and that's basically my last slide, isn't that just for FANG? It's not only Netflix, all these microservice business. And I was hoping to have a couple of references here on the slides, but I was actually not allowed to disclose them. So we currently have a couple of customers going in that direction, which are not Netflix. I discussed with Netflix actually about their engine architecture, but that's a different story. But kind of normal insurance companies, kind of big insurance companies, but also smaller ones, logistic companies. So I think as soon as the complexity and the size of the company is big enough, it makes sense to have a look at microservices. Doesn't fit all, but if you do, then you should come back to that. So I think that's kind of interested. If you're interested in, we have that flowing IO, which basically refers to the example. So this is the GitHub account where the whole example is hosted. I will put the slides online later on, just check my webpage. And yeah, that's it so far. Any questions? Yeah.
How can I decide what to put in the process? It's so difficult to decide what's too complicated and what's good enough.
So the question was, how do I decide what I put in the process? And yeah, I would say it's kind of a tricky thing. So it's not like a black-white answer. But as soon as it's kind of business motivated, as soon as you want to see it on that level, if it helps to have it visual, if you discuss that with like a lot of people in the project, not only business stakeholders, maybe also ops or other developers, then it might help to put it here. You don't want to model everything, because then you get like a huge picture which doesn't help anymore. So at some point you better put some stuff in code, or we can attach listeners everywhere, or you can also move it to a different level of the process, like calling a sub-process. So I would say only like business motivated things, which is still a kind of a gray zone. If you go to the blog post of the 7 sins, I gave a couple of examples there that might help. I think we can do one last question, because I'm not sure when they throw me out. Or we can wait until they throw me out. So, question?
Yeah, so if you talk about credit card payments, then of course the initial payment needs to be done by the customer himself. And how would you integrate this UI interaction in BPM?
You found the unrealistic part of that process. You're right. So the question was, if you look at that process, the credit card handling here, it's normally done by the customer himself for security reason on the web page. So it's not done in my back end. Yeah, if you do it like that, there are different possibilities to do that. So no, I don't quote the customer, then I can say more. So you could have already a running process in the background. If you say as soon as the customer goes to the checkout but still has to do the payment, it might already involve like a long running process in the background. And then, I mean, it's a kind of a UI thing, how you really display it then. But you get the information that you now need payment from within the backend somehow via an event, for example, over Kafka. And then you have to translate that to your UI. That depends very much on the UI. That's one thing of thinking about it. You could also say, no, in that case, the payment is not part of that game here. It has to be done before I had that order placed event. That's also a view on it. And it's, yeah, like I'm consultant, so I would say it depends on a couple of things. Any other questions? Yes. Okay, the question was how easy I find it, or how I found it in the past, maybe, to sell the idea of BPMN to developers. Hard to answer, actually. I'm kind of biased because I very often talk to developers which are already going in the direction of workflow. That's at least when I come to them. But it's kind of not that easy, to be honest. So the overall Java community, it's not that like 90% know of workflow and BPMN. That's always kind of, when I talk to Netflix, for example, they were like, yeah, but it's kind of, I mean, BPMN, it's XML. That's kind of legacy. It's not JSON. Or my developers will hate it. So it's kind of not that easy. So what normally works very well, if you approach it not from that BPM perspective, not like from, there's these BPM business methodology thing and kind of a huge thing and BPMN, but more like, okay, this handles a lot of your problems like state handling, timeouts, and a lot of things which you have to code yourself otherwise. And then it works pretty well. Then BPMN is kind of a piece of the puzzle. Yeah, that's what I would answer. I even have, I saw it, hang on a second. I even have done something pretty weird. If you look at the thing here, I even did like exactly for that use case. XML is kind of, I cannot use XML. I get, how do you say that in English? Pickle? whatever. I cannot use XML. That's impossible. I'm a developer. I have to use something else. Then I also did like a DSL, which in the background creates the BPMN XML. It's kind of, you can go through it. It's kind of a couple of lines of code. It's very easy. At the end, you get the same BPMN. It's runnable. You just don't see it. So it's not I think the BPMN should not be the showstopper. Yeah, Chris.
You said there are several engines available to use. Can you name them?
So the question was, there are several engines available to use. If I can name them, I could name them. Yeah, I'm. No, I mean, yeah, Camunda for sure. That's where I work. No, there are a couple of open source engines. So we share a history with Activity, for example. That's also an open source engine. There's from JBoss, there's something. So I think that's the three most Sorry? Probably not. I'm glad you said that, but he said that I wouldn't probably call the JVM lightweight. Yeah, I probably wouldn't, but as I said, I'm biased there. I shouldn't give too much answers there. I can always give that good answer. Try it yourself. I think that's an easy one. So, other questions? No? Okay, great. Thanks for coming. Enjoy the rest of the day.